All right, in this video, we will do what we would have done in class today, so you can work through it. One thing I would suggest to do is maybe pause the video at the start of each question, see if you can maybe do the question on your own, and then jump ahead to what the answer is. If you got it correct, then skip past that question. If you didn't get it correct, then watch that question being worked out so you can learn how to do it. Okay, so try and see if you can do it on your own, and then you got this to be able to check your work. So we have 600 students in a school, 400 use Instagram, 350 use Snapchat. If 400 students use Instagram or Snapchat, what is the probability that a student uses Instagram and Snapchat? Well, we have an or and an and. So we need to use our formula that has or and. Now that's a formula we've written on our inside cover of our booklet. You want to be studying that tonight and make sure you have it memorized. So that is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So there's 600 total students. For the or, they told us there was 450. So that would be 450 over 600 equals, we'll have A be Instagram, so that's 400 out of 600. The B will be Snapchat, so that's 350 out of 600. And then we don't know the and, so we'll just do minus x. So we're going to work to get the x by itself. So first, we're going to add our like terms there. Now, if you're doing this in the calculator, the answers would probably be reduced a bit, but there'd be the same idea. So if we add those, we would get 750 over 600 minus x. We would have to subtract the 750 over 600 to the other side. And when we do that, we would get minus 300 over 600 equals minus x. And we would divide by -1 to get 300 over 600 equals x. So that would be choice 2. Now, if you were typing this in your calculator all along, you would have gotten x equals 1/2. Well, what you would have had to do, you'd have to divide each of these to see which one would also give you 1/2. This one would have given us 5/4. Now that doesn't make sense for a probability anyway, because you can't have more than the total. This would have given us a 1/2. This one would have given us a 3/4, and this one would have given us a 1/12. Okay, so you would have just had to type them in to see which one matches. So here's the second question. Again, might be a good idea to pause the video, see if you can do the question on your own, and then just check your answer. So we don't have totals. So if you don't have totals in a chart, always find those first. So this would be 65, this would be 35, this one would be 54, this one would be 46, and if we added either down or across, we would get 100 here. Probably the student likes baseball given they are female. So whatever you are given, that is what you want to focus on, either row or column. So we will focus on only the female row. Well, in the female row, our total is 54, so that's going to be our denominator. And in that female row, we want to look for likes basketball, so that's 30. So we would just have 30 out of 54, which is choice 1. If they wrote this question in probability notation, it would be P. It would be likes basketball given they are female. Okay, so if they wrote it like this, the thing that comes second, that is your given, if by chance they wrote it in that notation. All right, next up, we want to know which expression is equivalent. Again, if you want to pause this, it would maybe be a good idea. Try it on your own and then skip ahead to see if you got the correct answer. So if this is a multiple choice, this is hopefully a slam dunk store question. Store something greater than 2 always for x, type in the original, type in the choices, see which matches. Okay, so you might have done that. Let's look at what the mathematical way would be for this. This would be a candidate for synthetic division because you have a 1 in front of the x. So you could have 1 out in front. Nothing's missing, so we'd have 1, 5, minus 3, and 2. Drop down the 1. We would multiply 1 with the 1 out front to get 1, and then we would add those to get 6. Multiply the 6 and the 1 out front to get 6, add them to get 3. Multiply the 3 and the 1 out front to get 3, add them to get 5. Our answer is always 1 degree less than we started with. We started with x cubed, so we'll have 1x squared plus 6x plus 3, and then we have a plus 5 over x minus 2 for our remainder. And let's see, that does not match. Oh, I messed that up. This should be a 2 out here. I'm not sure what I was doing. Let's start that over again. So we'll pretend like that didn't just happen. Out front, we have to put whatever makes the denominator 0, which is a 2. So we drop down the 1. We multiply 1 times 2 to get 2. Add them to get 7. Multiply to get 14. Add them to get 11. Multiply to get 22. Add them to get 24. So 1 degree less, we would have 1x squared plus 7x plus 11. And then our remainder, we have 24 over x minus 2. So hopefully that one matches up. And it looks like it does match with the fourth one. And again, you could have just done that with a store. Let's just real quick look at what long division would look like. Because if it had something other than 1 in front of the x, or if it was an x squared that we're dividing by, we would have to do with long division. So what times x gives us x cubed? It would be an x squared. So that would give us x cubed minus 2x squared. We're going to subtract, so we change both the signs. Now we just do whatever the signs say. So x cubed minus x cubed is 0. 5x squared plus 2x squared gives us 7x squared. And bring down the rest. So now what times x gives us 7x squared? That would be a plus 7x. So that's 7x squared minus 14x. We're going to subtract, so we have to switch both signs. Just do whatever the signs say now. 7x squared minus 7x squared is 0. Negative 3x plus 14x will give us 11x. Carry down the 2. So what times x gives us an 11x? That's an 11. Multiply through, we'll get 11x minus 22. We're going to subtract, so we got to switch the signs. This will give us a 24. That is our remainder. It's a positive 24, so we'll do a plus 24 over what we were dividing by, x minus 2. Okay, so there's 3 different options really for this question. Next one, number 4. So we're given a cubic function there, a polynomial. They tell us a, b, c, and d are positive constants. Which choice describes the end behavior? Well, one of the things I would do is I would put in positive numbers for a, b, c, and d. So let's like put in 1 for a, so we'll have 1x cubed. And we will do 2x squared plus 3x plus 4. Because now doing that, we could put that in a graphs page and see what the graph looks like. So you would get probably something with that shape there. And we would want to know the end behavior. Well, in each of these, we have as x goes to negative infinity and as x goes to positive infinity. X going to negative infinity is saying when you go far to the left. Well, we want to look at our graph, and far to the left, we are going down. So we would want one that goes x to negative infinity and y to negative infinity. So 1 is still in the running. 2 is ruled out because that said when we went to negative infinity for x, y went to positive. 3 is still in the running, but 4 can be ruled out. Well, now, as x goes to positive infinity, that's saying when you go far right, what direction is your graph going? And ours is going up, so it's going towards positive infinity. So for us, that would be choice 3. All right, so now on to some free response questions. We have the heights of ninth graders at FM High School are normally distributed with a mean of 63 inches and a standard deviation of 2.3 inches. To the nearest whole percent, what percent of students have a height between 63 inches and 66.45 inches? So hopefully in seeing that we have a mean, a standard deviation, we want between two things, we know to go to a calculator page. So we'll add a calculator page. We would go Menu, Statistics, Distributions, and Norm CDF. We would fill in our lower bound and upper bound, the 63 and the 66.45. And we'll go back to the question so you can see it and fill it in on your own. And then we would fill in mean and then standard deviation. Remember, if you're unsure of those, just go in alphabetical order. Now, because this is a free response question, we need to make sure we have some work. So we've got to write down what the calculator tells us. So we would get 0.433192 and some other stuff. Now, if this asked how many ninth graders, and they told us there was, say, 400 total ninth graders, we would multiply this right now by 400 and then round to the nearest ninth grader. But we wanted a percentage, so we'll move this over twice to switch to a percent. So that's 43.3192 and some other stuff percent. We want to the nearest percent, so we look at the first decimal. We have a 3. That keeps it the same, so we have 43%. Alrighty, number 6. Determine whether or not events A and B are independent. So when we see independent, we've written this down on our inside cover of our booklet, something you should be studying tonight. Our independence formula is probability of A times probability of B equals, with a question mark, because we don't know if they're equal, probability of A and B. So we're going to fill in. We'll have 0.2 times 0.6. Is it equal to 0.12? Now, if we had fractions, we'd want to make sure we type in each of them to see what they reduce to. On the left, when we multiply, we get 0.12. They do check out. This was the test for independence, so this would mean they are independent when they are equal. So we just need to write independent. Remember, if it says justify, that can always be done with either mathematical work or writing. If it says explain, you need to have at least one sentence. Next one, is x plus 4 a factor? Okay, if you think you can do this one, again, pause the video, see if you can do it on your own, and then just scroll ahead and check your answer. If you get it wrong, then come back and watch the explanation. So the easiest way to do this, if x plus 4 we want to know is a factor, we'll set it equal to 0, and we get x equals negative 4. That means that's our potential root. So we can sub that in for x and see what it gives us back for the remainder. Okay, this is called the remainder theorem, and it's telling us the number that is our remainder. Now you have to show this on your paper, but actually putting in your calculator, it might be easiest to do a store. So you can store negative 4 for x, type in the expression. When we do that, we would get negative 176, I believe. So we have to explain our answer. We would say, no, it is not a factor since the remainder is not 0. And I would include the word remainder somewhere in there to show that you have knowledge that the number that you just calculated, that you found there, is actually the remainder. All right, and our last one for this video. So Wesley was absent from school 23 days last year. A group of students was surveyed on the number of days of school they missed. And it was found to have a mean of 12 days and a standard deviation of 4. Assuming a 95% confidence level is the number of, that should say days, not day, days unusual compared to the students surveyed? Explain. So 95%, we want to think 2 standard deviations. Remember, 2 standard deviations can also be called the margin of error. So we will start with our mean. We will subtract the standard deviation twice. We'll start with our mean. We will add the standard deviation twice. When we subtract it twice, we get 4. When we add it twice, we get 20. So 4 to 20 would be considered the usual amounts. So Wesley had 23, so we would say Wesley's 23 days is unusual since it is not within the 2 standard deviation interval. Of 4 to 20. Okay, so that 95%, we want to think 2 standard deviations, and 2 standard deviations can be referred to as the margin of error as well. All right, so be studying your formulas that are on the inside cover that we've written of your big booklet, and we'll see you tomorrow.